Hey guys, I'm Siddhant Rao, your indeterminate dude, and lately I've been working on a project. So it's an RC aircraft, and what I've tried to do is make an RC aircraft which is like really cheap. So I've not bought off-the-shelf components like you do if you don't know anything about making an aircraft. What I've done is try to make everything by myself. And it's not a great idea, so I've not used anything like a Pixoc or the Tyrannus or X8R to just make an aircraft like plug and play. I've tried to make it like completely by myself. So what I've done is made a flight controller, as you can see, and secondly make the remote for it. So here's the remote, and what you can do is like just play around with this and control few things like say throttling a motor or say turning the aircraft in a certain direction. So this aircraft is going to be just having ailerons, so it does not have a rudder. So that's kind of a drawback, but I thought like we're just starting off, so let's start off small. So there are two purposes of making this project. One is to learn new things, and secondly, what I want is to just make something that I can fly by myself with just some amount of control. So in this video, you're going to be seeing some demonstration of what this system is capable of. And secondly, I'd be discussing about both the boards, the flight controller and also the remote control. And I'd be going into some amount of detail. If you are interested, keep watching. And in between, you're going to see some demonstrations like throttling the motor and say the autopilot mode. It's not exactly autopilot. It's more like having good orientation. That's the purpose. So let's first talk about the flight controller. Okay, so the flight controller consists of a few things. So on your screen you can see in the middle of the board there's an Arduino Nano. So that's going to be controlling everything right from communication to controlling and throttling motors and ESCs, etc. So that's the main chip right there. So that's the Arduino Nano having the Atmega 328P. Next to it you can see there's the HC12 module. So that's the radio communication module with the antenna right there. That's the circular coil that you can see. So the HC12 works on serial communication. It's a kind of a drawback, I know, but I had my reasons for choosing this. Next you can see on the right there's an MPU 6050. So that's going to be our inertial measurement unit, and it's going to tell us its orientation, and this whole MPU 6050, it's a gyroscope plus an accelerometer. So you get angular acceleration as well as linear acceleration. So apart from that, you can see there's a tiny switch right there. So that switch, it has two purposes. As soon as you click it, it's going to do two things. One, it's going to start searching for the remote controller, and secondly is going to set off the 0 point. So the purpose of setting the 0 point is that the inertial measurement unit that we have, this is the MPU 6050, it only measures angular acceleration. So it needs a 0 point to start off. If it had been measuring just the angle, that's the angular displacement, then we wouldn't have needed any 0 points. So that's the purpose of the switch. And apart from that, you have a buzzer which gives you some feedback. So let's say there's something wrong with the board, or say for example we're going to crash, something like that. So that's when the buzzer will be working, and also when you're pairing it with the remote. Next you can see there are a few channels. So you have three channels for servos. Two are for just the servo motors, and the third one is for the ESC. So the ESCs work very similar to a servo motor. They just need a PWM signal. So you can just use the servo library from the Arduino IDE and then work with a ESC. That is very similar to a servo. So that's pretty much all about the flight controller. So the remote houses an Arduino Nano as well. The main reason for choosing the Arduino Nano is it's very small and it has all the functionality that you have in the Arduino Nano, plus some additional analog pins. So as you can see on the screen, there are two joysticks. So the left, if you turn the left joystick up, it's going to throttle up the motor or throttle down the motor. Next, on the right, if you turn the right joystick to the left or right, then it turns the aircraft left or right, so it's going to roll in a certain direction. Next, if you just leave the right joystick at its position that's neutral, then it's not going to turn in either direction. Next, if you turn both the joysticks up together, it's going to start pitching up. That is, turn both the ailerons in a certain direction so that the aircraft starts pitching upwards instead of rolling. Next, if you turn both of them down, it's going to pitch down. Apart from that, there are a few other things on the board, as you can see. One is the C12 again, that was also on the flight controller. So it's again for wireless communication and it works on serial. Next, you have a black colored switch that's on the left. The purpose of the switch is for pairing with the remote pairing with the flight controller that is going to be controlling our aircraft. So what it does is it just pings a number and then the flight controller does some math on it and then returns the number. So if it gets if it gets the answer it's looking for when it's given the number on the serial port, then it's going to know, okay, we have the flight controller that's out there, because I don't want any other signal to be interfering while I'm flying. Next, you have a tiny buzzer right there, so it's just for telling us if we have if we have paired the flight controller with the remote. Next, you can see a knob on the right, that's a potentiometer. So what it does is it's going to set the sensitivity. So what I mean by setting the sensitivity is that, say you're throttling up, you want to throttle up very quick rather than slow. So you're going to turn up the knob. And it works for other things as well, like say you're pitching or rolling, everything is controlled by that knob. So if you want to, say increase the sensitivity, you can do that. And that is pretty much all about our remote control. Next we have the propeller. So the propeller I'm using is a 10-inch propeller and it has a 4.5-inch pitch and it is a clockwise rotating propeller, so I have to mount it in the reverse direction so that the aircraft moves forward. So the battery we're going to use, it's a LiPo battery and it's a 2200 milliamp hour battery which is 2 cells and can be charged up to 7.4 volts. You can definitely go up to like say 8.4 volts instead of 7.4, and it can supply a large amount of current that's required for the BLDC motor that we're going to use. Next we have the BLDC motor, which has 1000 kilovolt rating. So assuming that the battery is fully charged, that's 7.4 volts, and you can go probably up higher to 8.5 volts. The motor is going to spin at 7400 or say 8500 RPMs. That's like pretty quick, and it's enough for propelling our aircraft into the air. Next up we have the aircraft frame, and this frame is the VT Speedster V2, which is from Vortex RC. This is one of the things that I was not able to design myself because I had like absolutely zero knowledge as to how do you design an aircraft frame, and I didn't want to mess it up. So this is one of the things that I did not design, and in the next iteration of this project we'll have probably the frame designed by me, and it will be to a certain specification. And this frame that you're seeing right here, it's made up of EPP foam, and it's pretty good. It is laser cut by the manufacturer, and it has a balanced COG. So yeah, it's pretty good. It'll work for the project, so that's why I bought it. So first off, we have the wireless communication demo. So you can see the flight controller right here that's hooked up to the BLDC motor along with the LiPo. So the LiPo is also powering up our flight controller along with the motor. So it's supplying power to both. And as of now, the remote control does not have an external power supply. That will be added additionally in the next iteration. So first off, what you have to do is pair these two. So for that, you first click this button. So that's going to arm the flight controller, and then you hit this button on the remote for pairing. And then you'll hear this beep, and one is from the flight controller, second is from the remote. So it confirms that both of these understood that there was some pairing. And once it's done that, you can start playing around. So as of now, I've set the sensitivity at 0, and then you can turn the knob to increase it. Not 0 exactly, but it's at minimum. So what you do is turn this joystick up to increase the speed. So as you can see, it went up to its maximum speed, and then it made that sound. That's a feedback. So that feedback tells us it's at maximum speed. Then you can come back down. So as you can see, that took a lot of time. So let's say I want to throttle down very fast, or say throttle up very fast. So what you do is turn this knob up and then start throttling. So you can see this time it came to its maximum speed at very quickly. Then if you turn it back down, it's also going to throttle down very quick. So next up we have the auto orientation mode. So in this, let's assume the aircraft has no signal and it has to move in a straight line. Or let's assume that you're not turning left or right. So let's say you initially turn to the left. So you have to reorient to start turning right or left. So in this you can see if I start turning right, it will try to turn it to the left. So you can see those motors, they're going to be attached to the ailerons. So let's say let's say a gust of wind turns it to the left. So it's trying to orient to the right again. Let's say it's starting to pitch down. So what it'll do is it'll try to orient the motors in such a way that it starts pitching up. And let's say it's pitching up, so it'll try to orient it back down, try to pitch it down. And so you can, and it's real time. It's reading from the accelerometers and gyros, and it's pretty responsive, as you can see. So it can be like moving in any way, and it'll still try to reorient itself. So that's about it for all the demos. As you saw in the demos, it was able to auto orient itself, and then also throttle up and down, turn left, right. That is all well under what this flight controller is capable of. The problems here are there are a few problems here, and that's the reason why I've not had my first flight yet. So the thing is, you saw all the demos individually. What the issue I'm having is I'm not able to integrate these things all together. So there are two reasons why this is not happening. One is the communication method I'm using. So that's the HC12 module. There are two things that there are like this one thing good about that module and one thing really bad about that module. One is it uses serial, so it's very easy to work with. The drawback is it uses serial. So because it uses serial, you have a lot of noise, and secondly, you can have false packets. So because of that, what happened was I had to make a filter, and that filter, what it was doing was trying to get the right packets. So let's say you sent some information, and while traveling, it got some good amount of noise, and then that information that you received, that came out to be faulty. So I had to make a software filter to deal with that. And secondly, the thing is serial communication. When you increase the baud rate, it increases noise. So if you want to transfer information faster, it's going to be noisy. So that's a big deal. So say because that is the reason I was not able to control multiple channels. Let's say throttling and then also turning left to right. That is not possible. And secondly, the thing is, if I want to also have it auto orient and also have the raw functionality with the controller, the thing is, machines, all computers, they work line by line, and we have a single core machine. So what happens is, say let's say you asked it to turn left. So when you do that maneuver, what the controller will do is send that string to the flight controller, and then the flight controller takes that string, checks it, and then chops it down into pieces, then looks for all the pieces. Once it's got all the pieces, it converts that string into an integer, and then after converting it into an integer, what it will do is write that to the certain motor or ESC. So now between all of this, let's say, in this whole thing, it takes time. And because it takes time, you would probably have lost a few milliseconds here and there. And because of that, you just mess things up. So, if I just leave it for a second after turning left, it'll take a lot of time to start reorienting. And that will create a lot of jitter. and because of that jitter, there'll be, let's say if I was turning left and right and I was throttling. So when that it tries to cut down that string, take all the information out, and then do the job, what happens is that because of it taking time, what it will do is it will create that jitter. And if you have that jitter with a BLDC motor, you are going to have a horrible torque in the opposite direction of its rotation. So if you do that and fly something, you're definitely going to crash. So these are the things that are not going well with this project. So in the next update that you're going to see, there are going to be two Arduinos instead of one, or else I could change the radio communication method, which I'm not going to do because I've worked really hard to make that software filter to work with these modules. So what I'm going to do is have two cores. That's meaning that I'll have two Arduinos. One will control all the information part, like say I'm throttling up or down, turning left, right, pitching up, down, or say I'll also have a kill switch so that you can just instantly stop the aircraft. So that will be controlled by just one core. The second core job would be to just do the things, say turn left or turn right. The first core will decide, okay, do I have to turn left or right? And the second core will actually perform the task. So this accomplishes two things. One is that you will have communication reliably. Second is when you are reading and writing, there is no lag because you have another core. This is running on a completely different microcontroller unit. So because of that, you'll have zero jitters, and that will pretty much do what I want the flight controller to do. And once it's done that, I'll be hooking the whole system up onto my frame, and then you'll probably see the first flight. So I'm expecting the first flight to be probably in 2 to 3 weeks. It probably will take longer, but I'm just being optimistic here, and I'm really horrible with timelines. So I hope you enjoyed the video, and this is all for this one. So that is it for this video, and I hope to see you again. And if you really like the project, you can just hit that like button, also subscribe. And I'm very happy to say I've already reached 100 subscribers. I know it's a very small milestone, but it's still a milestone, so I'm very happy about that. And next up, in the next iteration, this is some stuff I'd like to speak right here. In the next iteration, that's the next version, not the one I was talking about earlier. In the next version, when I actually get serious with this project, what we'll have is a PCB. So on that PCB, everything will be integrated all together instead of just that PCB which is being soldered by me. First off, it's very unreliable. Sometimes BIOS break off. I don't enjoy that. it's it's like horrible. Sometimes you can see some things are shorted just because you soldered it wrong. Next up, the frame will be completely designed by me, and you'll be seeing a lot more things up in the frame as well. So I hope you come back, and I'll be posting the first flight video. I don't care if it actually flies or if it crashes. You're going to have the first flight video on this channel, and after that you will be seeing all the new updates on the flight control as well. So that's it for now. I hope you enjoyed, and I'll see you guys very soon. Peace.